Okay, actually I just fixed the picture, so this is all right. Okay, everything outside of the kernel is the row space. Okay, everything in the kernel maps to 0. Everything outside the kernel is in the row space. And everything in the row space except the 0 vector maps on to a non-zero vector over here. That's a picture you just kind of need. And if you have one row of zeros here, your kernel has dimension 1 and your row space has dimension 2. If you would get 2 rows of zeros, then your kernel would have dimension 2 and your row space would have dimension 1. The whole point, or one summary of this discussion is simply that the dimension of the kernel plus the dimension of the row space equals the dimension of this space here. And in that case it would be 3, okay, for this picture and for this matrix. Also, I think I mentioned it, but the image space consists of all the vectors that you can get from vectors in R3. Okay, there might be vectors here that you can't get by this transformation. And in fact, if the kernel has dimension 1 or greater, there will be vectors that you can't get from this transformation. The image space consists of all the vectors that you can get that have all the vectors that have what we call pre-images over here, all the vectors over here that come from something over here. Okay, now, it might be that every vector in R3 has a pre-image over here, a vector over here that maps onto it. But it might be that there are vectors over here outside of the image space that don't come from anything over here. Again, that's going to be the case if the kernel has dimension 1 or greater. Now, why is that? Well, if the kernel has dimension 1 or greater, then the dimension of the row space is going to be less than 3. Well, the dimension of the row space equals the dimension of the column space, so the column space, which is the image space, has to have dimension less than 3. Now, R3 has dimension 3. If the image space has dimension less than 3, that means there are vectors out here that aren't in the image space. Okay, so it would be the situation that we've drawn here. Now, we'll be talking about this quite a bit in the future, but it's an idea you want to grab onto.